Picture the ocean floor for a second. It's this incredibly vast, mostly lightless alien world, right? Well, it turns out it's been hiding a massive biological mystery that has totally baffled scientists for nearly 46 years. We're talking about deep-sea hydrothermal vents. These crazy underwater hot springs that support vibrant, strange ecosystems. But, there's always been this missing piece to the puzzle of how these ecosystems actually function. So today, in this explainer, we're going to dive into a groundbreaking discovery that literally flips everything we thought we knew about life on the ocean floor upside down.
65,000. That's a pretty staggering number. It represents the kilometers of mid-ocean ridges wrapping around our planet, kind of like the seams on a baseball. In these deep ocean trenches, brand new oceanic crust is being forged in complete darkness. It's basically an immense underwater factory where more than 2/3 of the Earth's skin was born. But here's the thing. It's not just a geological factory, it's a biological one too.
And that brings us to the central biological enigma of this whole deep sea ecosystem. Whenever tectonic activity creates a brand new hydrothermal vent, a thriving ecosystem rapidly colonizes the area in just a few short years. Tube worms are the foundational animals in these communities. But here's the bizarre part. Scientists rarely, if ever, found the young larvae of these tube worms in the seawater above the vents. Think about it. If they aren't swimming through the water column to get to a new vent, how on earth are they getting there? Well, before we can solve that mystery, we really have to understand the violently explosive geological forces that create these environments in the first place.
So to figure this out, we need to look at part 1, setting the stage and the violent birth of the seafloor. Let's rewind a bit. Back in the 1960s, Harry Hess used echo sounding data from his naval service in World War II to propose the concept of seafloor spreading. He formally published this in his 1962 paper, History of Ocean Basins. Then, the very next year, the Vine-Matthews-Morley hypothesis used magnetic reversals in the crust to actually prove Hess's theory. So for decades, we knew the seafloor spread, but we thought of it as the slow, steady geological process. That is until April 2024, when scientists finally caught the Earth in the act and witnessed the birth of oceanic crust in real time.
Here's what happened. In early 2024, an international team set up the Oche Geodams experiment at the southeast Indian Ridge near Amsterdam Island. They placed autonomous hydrophones right on the seafloor. Now, they were really just hoping to measure a steady, slow stretching of the ridge, maybe a few centimeters. But instead, they caught what they called a quantum event, a massive, sudden, cataclysmic tearing of the Earth's crust that hadn't been observed like this in 40 years. The crucial takeaway here is that seafloor spreading isn't just some continuous creep of 6.3 centimeters a year. No, it happens in devastating, rapid bursts. In just a couple of hours, accumulated magma ripped right through the crust, injecting an estimated 150 million cubic meters of molten rock. To put that into perspective, that's enough to fill tens of thousands of Olympic swimming pools. It drained the magma reservoir so fast that the seafloor faults collapsed by a staggering 4.2 meters, letting lava erupt directly onto the ocean floor. And when that seafloor cracks, fractures, and collapses like this, it creates an intricate network of deep, warm cavities, which perfectly sets the stage for a truly unprecedented biological expedition.
Which brings us to part 2, the hydrothermal underworld, searching beneath the cracks.
All right, let's jump to August 2023. The Schmidt Ocean Institute launched a massive 30-day expedition aboard their research vessel Falkor, too. Led by Dr. Monica Bright from the University of Vienna, an international team headed down to the East Pacific Rise, about 2,500 meters deep. They had this wild theory about where those missing tube worm larvae might be hiding. So they used an underwater robot, ROV Sebastian, to do something absolutely incredible. They literally flipped over heavy chunks of the Earth's volcanic crust.
Now, for 46 years, we've only studied the habitats above the seafloor. Animals thriving on the vents, depending on the oxygen from the cold seawater up above. But below the seafloor, when they overturned those rocks, they found an entirely new, hidden ecosystem living in these subterranean cave systems, bathed in 75-degree Fahrenheit water. It was a completely unknown world existing right beneath the one we already knew.
You're probably wondering, what actually lives in these dark subsurface cracks? Well, the team found these cave systems were just teeming with extremophiles. They discovered chemosynthetic bacteria, snails, different kinds of worms, and, this is the huge part, multiple young tube worms, including the Oasesia and Riftia species, just thriving, nestled within the rock samples.
Boom! Mystery solved. How do they colonize new vents?
The team actually proved it by gluing mesh boxes over cracks in the crust. When they removed them days later, animals had moved in from below the surface. Dr. Bright's team confirmed that these foundational animals don't swim through the freezing ocean water above. They travel beneath the seafloor. They use the warm vent fluids moving through the cracks in the Earth's crust to colonize brand new habitats. They literally travel through the underworld. This discovery is a real game changer, but it also highlights why understanding these interconnected deep-sea habitats is so absolutely crucial for us today.
And that leads us to part 3, a vulnerable new ecosystem, and protecting what we barely know.
Dr. Jyotika Vermani hit the nail on the head here. On land, we've known about underground animals for a long time. But in the ocean, this is a total first. And while it's an amazing testament to life's resilience, Dr. Vermani notes that these newly discovered, highly complex systems may be extremely vulnerable to impending industrial activities, like deep-sea mining. It's a pretty stark reality. We're finding entire ecosystems at the exact same time they're facing major potential disruption.
Wendy Schmidt echoed this sentiment perfectly, pointing out a massive takeaway: the sheer urgency of exploration. This expedition proved that there is a whole other dimension to hydrothermal vents. The habitats exist together, above and below the surface, as one interconnected system. We literally cannot protect what we don't yet know or understand, which makes our intelligent observation of the deep sea more crucial now than ever before.
So here's a thought to leave you with. If a 46-year-old mystery was solved simply by looking underneath the rocks we've been staring at for decades, what else is down there? As artist Max Hooper-Schneider noted during the expedition, these lightless ecosystems are key to understanding the extremophilic dawns of planet Earth. If a vibrant, thriving ecosystem can exist in the hot, dark, violent cracks of our planet's crust, what other hidden worlds are just waiting to be discovered right beneath our feet?